So now that we know the different types of discontinuities, we can look at what makes the graph actually continuous. So a function f of x is said to be continuous at x equals c. I'm not sure if you've seen this before, but that means if and only if. So if you go on to higher math level classes, we use that a lot in proofs. If and only if. So if and only if these three things are true. So the first thing that has to be true is the limit of f of x as x approaches c has to exist. So remember, that means the left side and the right side meet at the same spot. Number two is the function itself actually has to exist. So what that means is there needs to be a solid dot. So like f of 2 equals like 5. So that would be that existing because there's a solid dot. And then the final trait is that your limit of f of x as x approaches some c needs to equal that f of c. So what that's saying is the left and the right side have to meet where that solid dot is. So looking at examples, it says answer the following questions for each c value listed below. So is the function continuous? And then if no, which part of the definition does it fail? So it's saying at c equals 0, so like at x equals 0, is it continuous? So the first test is, does the limit exist? So when x is 0, the left and the right sides meet, so we're good. Step 2 is, does the function exist? And yes, it's solid there. And the left and the right side meet where it's solid, so this one is continuous. So you don't have to think about those tests every single time if you can just think about it quickly in your head, but that one is clearly continuous. Then at c is 3, so when x equals 3, so 1, 2, 3. Here, hopefully you can see right away there's a lot of jumps here, so this one is not going to be continuous. And this one fails out of our steps. The limit does not exist because the left and the right side don't meet. And then does the function exist? Yep, there's a solid dot, so it's going to fail test number 1. And then if it fails test number 1, it also has to fail test number 3. Because remember, test number 3 says that the limit has to equal the solid dot. And since the limit doesn't exist, then it can't equal the solid dot. So this one fails both 1 and 3. Then at 7, so 1, 2, 3, 4, 5, 6, 7. Solid line, left and the right sides meet, so we're good. So this one is continuous. At x is negative 3. Hopefully you notice right away there's a discontinuity. There's that hole there. So the limit exists because the left and the right sides meet, but there is no solid dot. So that fails test number 2. And then because it fails test number 2, it also has to fail test number 3 because they can't equal if it fails one of them. So it fails 2 and 3. And then at x is negative 6, 1, 2, 3, 4, 5, 6. Right away, you should hopefully see that asymptotic discontinuity. So this one is going to also fail. So this one is not continuous. And it fails. First test is the limit exists. So left and the right sides don't meet, so it fails number 1. There is no solid dot because there's an asymptote, so it fails number 2. So it also has to fail number 3. So in your practice problems, I believe you're going to be labeling, you're going to be given a graph, and then it's going to ask you, is it continuous or not? And then which test does it fail? So you'll be using the whole 1, 2, and 3 to show which test it fails. So why don't you guys go and try those problems.